Okay, getting back to quadratics, we're going to talk a little bit about the zeros of, the zeros of a quadratic. Just going to get my pen working. The zeros of a quadratic. So these, or other names for it, is the x-intercepts or the roots. Okay, and of course we're looking at the place on the graph. Here's our parabola. We're looking at these points here. Of course, a quadratic doesn't necessarily have to have x-intercepts. It will always have a y-intercept. Somewhere along the line, a quadratic must touch the y-axis. That's why we call it the y-intercept, but it doesn't have to touch the x-axis. We could have a quadratic that looks like that, for example, a frowny face, or that's below the x-axis, or we could have a smiley face that's above the x-axis. In that case, we wouldn't have any zeros. We couldn't find them. We couldn't solve the equation. So remember, our general form is y equals ax squared plus bx plus c, where our a, b, and c, these are all coefficients. Okay, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term or the coefficient of x to the naught. Okay, going back. Sorry, get that done. Also, our strategies to find the zeros. It's basically three of them. First one that we use is factorization. We're going to try with the z, yeah, factorization. The second one is what we call the quadratic formula. And the last one is the completing the square. Okay, and we'll deal deal with these two in this little section. Okay, so I'll give you an example of factorization. We'll start with factorization. So we got y equals x squared plus, say, 6x plus 9. Okay, just going to start with these ones. We're going to start with ones where the coefficient of x squared is 1. So these are ones where the case with a equals 1. We'll start with those because they're the easiest. So the way we start is we look at this number here, 9. I'm going to write plus 9 here, and down here I'm going to write the factors of 9, 1 and 9, minus 1 and minus 9, 3 and 3, and minus 3 and minus 3. And what I want to do is I want to find which pair of these, when I add the numbers up, will give me this number here. And of course it's this one here. So this can be rewritten as x plus 3 times x plus 3. And of course if you multiply out these brackets using the FOIL, you'll end up getting back to that. So if you apply the FOIL on here, you'll go back to this original thing. Now, the point being, this is where we use the null factor law, because if we want to find the zeros, this is where y equals 0. Y equals 0. That's what we mean by the x-intercepts. And by the null factor law, that means that either x plus 3 equals 0 or x plus 3 equals 0, which is exactly, these two in this case are the same. And these imply that x equals minus 3. This is what we call a double root. Okay? A double root. And it's the case where, and this one is going to happen over here, but I'll just draw here, is when the quadratic comes down and I didn't quite do it as usual, never quite do it when I draw things, it just touches Just touches, doesn't cut through, but just touches the x-axis. It's not, doesn't intercept it, it just touches it. Okay, so that's an example there. Give you another example now. So I'm going to take y equals x squared minus 25. Now this is a different one because this one here, we call this the difference of two squares. Because if you look, we've got two numbers squared. Here's x squared, and here is actually 25, which is actually 5 squared. So we can write this as x squared take 5 squared. And here's the crazy thing, and there's no x term, so b equals 0. We can just note here, b equals 0. And we can factorize this really quickly. It's actually x plus 5 times x minus 5. Okay? So in general, if we've got x squared minus a squared, we can factorize that as x minus a times x plus a. And okay, using the null factor law to find the zeros, this implies that either x plus 5 equals 0 or x minus 5 equals 0. This one implies that x equals minus 5. This one implies that x equals 5. So we go back and there's our two roots. So minus 5 and 0 would be one root, and 5, the point 50, would be the other root. Okay, let's try another example. Try y equals x squared minus 8x. So this is a case we've got c equals 0. And of course we've still got a equals 1. We'll leave it like that. So this one to factorise, if you see there's a common factor here of x. So I can just factorise this by going x outside of x minus 8. Okay, because if we do expand that bracket, and remember the bracket's expanding rule, a times b plus c equals a times b plus a times c. Sorry, that's a c. And once again, if we make this equal to 0 to find the x-intercepts or the roots or the zeros, this implies that either x equals 0 or x take 8 equals 0. And this one implies that x equals 8. So 0, 0 is one of our x-intercepts, and 8, 0 is our other. So that's meant to be an 8 there, yeah. Okay, we'll just leave it there. Have a think about that. Have those techniques. Go back and think about them. And if you need to come back, have a look at them later.